You know, every single breath you take, every beat of your heart, it's all happening inside this incredibly well-protected vault in your body called the thorax. So today, we're going to take a guided tour of that vital space. All right, let's dive in.
I mean, it's just this constant buzz of life-sustaining action in there. But what are the actual parts, the gears and levers that make it all happen? Let's peel back the layers and take a look at the incredible machinery that's working inside you right this second.
So I want you to think of your thorax as the body's high-performance engine room. Seriously, it's this beautifully designed protective structure, and it's housing the critical machinery that literally powers your entire life.
Right, it's all protected by your rib cage, and inside this cavity is where all the magic of breathing and circulation really begins. It's home base for your heart and your lungs, two organs that have to work in perfect, non-stop harmony. So let's start our tour by following the very air you breathe.
Okay, our first stop on this tour, we're going to follow the amazing journey of a single breath from the outside world deep, deep into your lungs. And it all starts with one main highway.
So air comes in through your nose or mouth, and then it travels down your trachea. You probably know it as your windpipe. Think of it as the main expressway for air. But, like any good expressway, it eventually has to split off to deliver its cargo to different places. And that brings us to a really key structure.
See, right at the base of the windpipe, there's this very specific anatomical landmark where the whole airway divides, one path going to your left lung and one to your right. Any idea what that spot is called?
It's called the carina, and it's basically this little ridge of cartilage that acts like a traffic cop, sitting at the exact point where the trachea splits into the two main bronchi. It's such a simple little thing, but it's an absolutely critical piece of our respiratory architecture, making sure air gets distributed exactly where it needs to go.
So once the air is in the lungs, they're constantly inflating and deflating with every single breath. Now, that is a ton of movement happening inside your chest. To stop everything from, rubbing together and getting damaged, the lungs are surrounded by this thin layer of fluid. But what's the stuff actually made of? Okay, this is the amazing part. Just how simple this solution is. Get this, pleural fluid is 95% water. Just water, with a tiny bit of protein and some electrolytes thrown in. This super simple watery lubricant is all it takes to let your lungs glide smoothly inside your chest thousands and thousands of times a day. Incredible.
Okay, so we've got the pathway for the air and we've got the lubrication, but what's providing the actual power for breathing? For that, we need to check out the powerful muscles that drive this whole process.
Now, your normal, everyday, quiet breathing is handled by one main muscle. But what about when you're exercising hard, or you really need to gasp for air? That's when other accessory muscles get called in to help. So which muscle is a key player when you need to take a really deep, forced breath in?
The answer is the sternocleidomastoid, and you can actually feel this one on the side of your neck. When you absolutely need to max out your air intake, this muscle contracts and literally pulls your sternum and your ribcage upwards. That creates even more volume in your chest so your lungs have more room to expand.
And this table really shows the division of labor here. For just chill, quiet breathing, your diaphragm does most of the heavy lifting. But for a deep breath in, specialists like the sternocleidomastoid are called up from the bullpen. And for a forceful breath out, think blowing out birthday candles, well, the internal intercostals take over. It's a highly coordinated team effort.
So, we've covered the breathing part of the equation. Now let's shift the focus of our tour to the other superstar in the thorax, the heart. We're going to look at the dedicated plumbing that keeps it and its supporting muscles up and running. All right, here's a great question that really gets to the, heart of the matter. The heart is a muscle, and it needs its own blood supply. It gets fresh, oxygen-rich blood from the coronary arteries, sure. But after it uses up all that oxygen, how does it get rid of the waste? Where does that used blood go?
Turns out, the heart has its very own dedicated drainage system. And the main pipe in that system is the coronary sinus. It's this large vein that collects pretty much all of the used-up blood from the heart muscle itself and dumps it right back into the right atrium, ready to get sent back to the lungs for more oxygen.
Now, what's really cool here is how specific these jobs are. You might think, oh, it's got to be one of the big vena cava veins, right? Nope. They're busy handling drainage for the rest of the upper and lower body. And it's definitely not the pulmonary veins. They have the opposite job, bringing fresh, oxygenated blood from the lungs. The coronary sinus has one very important job, draining the heart itself. That's it.
And speaking of dedicated supply lines, let's connect our two topics here. The main muscle of breathing, the diaphragm, sits right there below the heart and lungs. And just like the heart, This tireless muscle needs its own robust blood supply to keep on working, breath after breath.
Now, while there are a couple of arteries feeding it, the main player here is the inferior phrenic artery. It actually comes up from the aorta down in the abdomen and provides the bulk of the blood. The superior phrenic artery helps out a bit at the top, but really, the inferior one does all the heavy lifting. It's just another perfect example of specialized plumbing, ensuring every part of the engine gets the fuel it needs.
So let's zoom out and put all these pieces together. We've seen all these individual parts, right? The airway, the muscles, the veins, but the real marvel is how they all work together as one single elegant machine.
Think about it. The precise design of the carina, the simple fluid that lubricates the lungs, the teamwork of all those different respiratory muscles, and the dedicated blood vessels just for the heart and diaphragm, none of these things work in a vacuum. They are all perfectly interconnected parts of this amazing machine, and it's all designed for one purpose, keeping you alive.
The big takeaway here is that this unbelievably complex, life-sustaining system is just humming along inside of you, right now, without you even thinking about it. It kind of makes you wonder, what other incredible biological marvels are we just overlooking in our own bodies every single day? Thanks for joining us on this tour.